Hello everyone, my name is Lisa Nichols and today I'm going to show you how to run a TLC or a thin layer chromatogram in order to separate components of a mixture. I'm going to run two TLCs side by side. On the right, I'm going to do some colored substances, a red and a blue food dye, and on the left is going to be a colorless organic substance. So the first thing is to prepare your TLC chamber, and you'll want to put a piece of filter paper inside of it. If your paper is small enough that when you stick it into the chamber it doesn't obscure your view, then you're fine, but you might have to cut it down to size. TLC chambers can be like a tall screw-capped container, or it can also just be like a beaker with a watch glass over top of it. And so you put that filter paper inside. And now very quickly I'm going to set up the second TLC chamber in the same way. Next, I'm going to add liquid to the TLC jars, and you choose different solvents based on what you're trying to separate. So for the food dyes, I'm going to use a mixture that has different alcohols as well as ammonia in it. And then for the one on the left, I'm instead going to use a hexane and ethyl acetate mixture. So you would add the liquid, put the top on, and then turn it upside down and kind of wet the filter paper and shake it around. And what you're trying to do is to create an environment that is saturated with solvent vapors. So when you put the TLC plate into this chamber, liquid is going to climb up the plate and travel upwards. And so if we had just done this out in the room, as it travels up, it's going to evaporate and it's going to dry out. So by putting it inside this enclosed space, as it runs, it's not going to dry out and it's going to stay wet and it's going to keep on climbing up the plate. Next, I'm going to prepare my TLC plates. So the ones that I use have silica gel, which is a white powder, deposited onto a glass backing. So when I turn this plate around, you'll be able to see that there are some reflections with the light in the room, so you can see that that's glass. The other side is the silica gel, where it's more muted, and that's where you want to actually put your sample. You also want to be delicate with the silica gel, so don't put your fingers all over it. Try to hold it by the edges. So we're first going to draw a baseline using a ruler and a pencil, maybe like a centimeter or so from the bottom. And you want to do this lightly, like don't draw a thick line or like gouge the silica, just like a very light line. And then next you want to label the lanes of where you're going to put your sample. Don't do it too close to the edges, kind of, use the middle space. And if you only have two samples to analyze, you're going to do 2 lanes, but for this TLC plate, I probably could fit 4 lanes if I needed to. And next, let's put our liquids onto the TLC plate. So TLC has to use dilute solutions. If you instead try to use pure samples, you're just going to get blobs. It's not going to work. So for the food dyes, I made up solutions that had 5 drops of water to 1 drop of food dye, so they are dilute. So I'm going to use a capillary tube and put that into the solution. It's going to naturally draw up a small amount of liquid, and then you put that onto the TLC plate in the lane where you want to deposit it, and use kind of a quick down up motion to just deposit like a very small amount and make a very tiny dot. You don't want these to be big, so it should be about 2 millimeters, maybe 3 millimeters in diameter at the maximum. And then the excess, I would have just kind of put that onto a paper towel, and then I have another jar of solvent to kind of rinse it with the food dyes. Water actually rinses it really well, because if you then use that capillary tube to deposit the blue dye, well, you're going to be mixing the red and the blue together, so you do have to clean out the capillary tube. And another thing is you don't want to set the capillary tube down like on the paper towel horizontal while there's still liquid in it, because very likely you're going to get an air bubble to go into there and then it won't drain out very well. There are ways to kind of get around that, but it's best to just avoid it in the first place. So when you're using the capillary tube, you put it in the liquid, you drain it onto the TLC plate, and then immediately drain it onto the paper towel and get all the liquid out, because then you'll be able to use it multiple times. So after I've rinsed it with water, I'm now ready to do a different sample. So here I'm putting it in the blue food dye and, put that onto the blue lane, very small dot, drain it out immediately, right? And then rinse it, and then you're ready. Okay, so now let's put the TLC plate into the chamber, And so you can pick it up with forceps and gently set it inside the chamber where the sample is on the bottom, and so it will just touch that liquid. You actually don't want those spots to be submerged in the liquid, then they will actually just dissolve out into the liquid. You want them to be higher than the liquid. And then you will just put the top on and you don't touch it, you just let it sit there and let it run. And while that's running, I'm going to prep the second plate much in the same way. I'll put the capillary tube into a sample. I'll deposit a small dot of that onto the plate, drain out the majority, and then rinse it. And this time I'm rinsing with acetone instead, and then do the second sample. And if your concentrations are right, you just need to do one dot. Sometimes though, if you know your sample is very dilute, you might actually do multiple spots over top of each other. And not a bad idea to remember to put those caps on so that you don't spill. Then I'll put this second plate inside its TLC jar and we'll let it run. And let's see what's happening with these TLCs. So in the interest of time, I have actually sped up the video to about 5 times the speed, but we can still watch what happens. So on the right with the food dyes, we're starting to see that there is some separation of colors. So on the far right, we spotted a blue dye, but notice that there's like this little dot of red inside there, right? So blue food dye actually does have a red component in it. So they actually put that in there to give a slightly different appearance or a different like shade of blue. And on the left of the food dyes, that's the red food dye, there's actually a pink component and a red component. So that's also a mixture. And that's really the point of TLC, is being able to separate out mixtures. You want to let the TLC run until the solvent front, which is like the wet area, it gets to about 1 centimeter or so from the top. And this will take different amounts of time based on the solvent. So with the food dyes mixture, that really clings to the silica, and so it runs really slowly. That probably would take 45 minutes to complete. But if you use a less polar solvent, like the one on the left, this one probably would take only about 5 minutes. When the TLCs are done, you can then take them out with forceps, and the solvent is going to evaporate really quickly, so you want to immediately mark the solvent front, which is the highest that the liquid went, with a pencil. If you don't do that right away, that solvent is going to evaporate on you and you won't know how far it traveled. And that is how you run a TLC.